You know that feeling when you're looking at a photo and you just wish you could, I don't know, step right into it, maybe peek around a corner or see what's just outside the frame? Well, that's not really science fiction anymore. It's happening. And today, we're going to look at a crazy new breakthrough that can take just one single, flat picture and basically unlock a whole 3D world hidden inside it. I mean, really think about that for a second. What if any photo could become a 3D scene? You could take that great vacation pic and actually fly around the mountains. Or say you're shopping online. You could grab a picture of some new sneakers and spin them around. Look at them from literally any angle. This is way bigger than just some cool special effect. We're talking about completely changing the game for how we even think about 2D images. So, there's a technical name for this kind of magic. It's called novel view synthesis. Sounds a bit fancy, but the idea is actually super simple. Novel just means new. So the whole goal is to create a new viewpoint of a scene from a completely different perspective, starting with just one original picture. And believe me, a brand new AI model is taking this idea and running with it, pushing the limits of what we thought was even possible. All right, so here's what we're going to cover. First, we'll dig into why this is such a tough nut to crack. Then, we'll meet the star of the show, the diffusion transformer, and figure out what makes it tick. It's secret sauce, if you will. We'll put it head-to-head with the competition to see how it performs, and then we'll wrap up by looking ahead at what all this means for the future. Let's get into it. Okay, so first up, the single-view challenge. Why is this so ridiculously hard? Well, our brains are amazing at this, right? You look at a photo and you just get the 3D space. But for a computer, it's a whole other story. A flat picture is full of missing information. What's behind that tree? How tall is that building, really? Teaching an AI to imagine all those missing pieces and fill them in realistically, that is a massive, massive challenge. Now, it's not like people haven't tried this before. There are some powerful methods out there, like NeRFs, that stands for Neural Radiance Fields, and they can do some incredible stuff, creating these beautiful 3D scenes you can just fly through. But, and this is a big but, they are incredibly hungry for data. A standard NeRF doesn't just need one photo. It needs dozens, sometimes hundreds of pictures of the exact same thing, all shot from different angles, and you have to know exactly where the camera was for every single shot. It's a huge pain. And that right there really shows you the gap we're trying to close. In one corner, you've got the old way. You need a mountain of perfectly staged photos, it works best for a single object sitting in a studio, and it takes forever to process each new scene. And in the other corner, you have the dream, the holy grail, a model that can take just one image, any messy real-world photo, and give you a 3D scene like right away. And that's exactly the problem this new model is built to solve. All right, it's time to meet the hero of our story, the Diffusion Transformer. This is a brand new model built for the real world. It's designed to handle all the messiness and unpredictability that comes with it. So instead of needing that perfect, pristine dataset, it actually learns from casual videos. Yeah, pretty much the kind of stuff you just shoot on your phone. Okay, so DT-NVS. The name sounds like a mouthful, I know, but it actually tells you everything you need to know. It's a mashup of two of the biggest technologies in AI right now. You've got diffusion models. Those are the AIs that are absolutely incredible at creating realistic images from scratch. And you've got transformers, the architecture that's amazing at seeing the big picture and understanding how everything in the data relates to each other. You smush those two together, and bam, you get a model that's actually aware of 3D space and can cook up brand new viewpoints on command. So here's how it works. Think of it like a little assembly line. Step 1, you give it a single photo. That's it. Step 2, the transformer part gets to work. It's like the architect looking at that flat picture and sketching out a full 3D blueprint of the scene. And then, step 3, the diffusion part comes in. It's like the master painter who takes that blueprint and creates a stunning, photorealistic new painting from any angle you want. It's pretty amazing. Okay, this is the part I love, the secret sauce. How in the world does this thing learn to think in 3D so effectively? This is where things get really, really clever. The researchers didn't just do the obvious thing and, throw a bigger computer at it. Nope. They came up with a genius trick that changes how the model learns from the ground up. And this quote from the paper itself gives us the biggest clue. Basically, during training, they'd show the model two images from a video. One was a clean reference photo, and the other was a noisy or distorted version of a different viewpoint. The AI's job was to fix the noisy one. But here's the twist. They would randomly swap the positions of noisy input images with reference images. And that little swap, that's the genius of it. It's a simple trick, but it stops the AI from cheating. See, if the reference image was always the same one, the model might just get lazy and learn to copy and paste pixels. But by randomly swapping them, you force the AI to actually understand the 3D geometry of the scene. It has no choice but to build a real mental map to figure out how the two views relate, because it never knows which one it's going to get as the target. It can't just copy, it has to think. And that wasn't the only trick up their sleeve. They threw in a few more clever ideas. For example, instead of bogging the model down with complex camera coordinates, they taught it to think in terms of relative positions, which is just way simpler. They also figured out a smart way to feed that camera info directly into the model's, into its brain. And on top of all that, they used a really efficient way to represent the 3D scene so the whole thing doesn't grind to a halt under a mountain of calculations.
So the ideas are brilliant. The theory is solid. But the big question is always the same. How does it actually perform? It's time to put DT-NVS to the test and see how it stacks up against the rest of the world.
Okay, let's look at the numbers. This is from a real-world video dataset called MVImgNet. The score we care about here is the FID score. All you need to know is that it measures how realistic the final image looks, and a lower score is better. As you can see, DT-NVS comes in at 31.82. That's not just a little better, it soundly beats the competition, including another big diffusion model. This is, without a doubt, the new state of the art. But forget the numbers for a second, because just looking at the results tells the real story. The older models, they often spit out stuff that's kind of blurry, or they get the scale all wrong. Things just look weird. DT-NVS, on the other hand, creates scenes that are sharp, they make sense geometrically, and they're just way more stable and coherent. The difference is night and day. And when you test it on synthetic data, like in a controlled lab environment, that's when things get truly wild. On this dataset, DT-NVS scores a ridiculously low 14.9. I mean, look at that chart. It's not even a competition. It absolutely blows the other models out of the water. 212%. Let that sink in. On some of these tests, that's how much better it performed than other diffusion models. A number like that, that's not just a small step forward. That's a giant leap. It's a true breakthrough. Okay, so we've established that DT-NVS is an absolute beast. It's a seriously powerful new tool. But what's next? What does this mean for everything? Where are we going from here? First things first, let's talk about the current limits. The researchers are really upfront about this. Right now, the biggest issue is resolution. To get this thing to train on the hardware they had, which was just a couple of GPUs, they had to shrink the images down. So all these amazing results are actually at a pretty low resolution. But, and this is key, that's just a hardware problem. It's not a flaw in the idea itself. As computers get faster, this problem will just disappear.
But man, once we get past that resolution hurdle, the possibilities are just insane. Imagine being a game developer. You draw one piece of concept art, feed it to the AI, and boom, you get a 3D model ready to drop into your game. Or for VR, you could snap a few photos of a real place and build a whole explorable world. Think about e-commerce. You could look at a pair of shoes from any angle you want, all from one standard picture. The creative doors this opens are just endless.
And that brings us to the final big question to leave you with. How is this going to change the way we create and even interact with digital worlds? We're really standing on the edge of a new era here, where that line between a 2D picture and a 3D world just gets blurrier and blurrier. A tool like this, one that can find the hidden depth in any photo, it does more than change how we make video games. It changes what a picture even is. It turns a static moment into a dynamic, explorable space. So the real question isn't just about what we're going to create with this technology. It's about how it's going to change the way we see our world.